Welcome, Algebra 1. We are going to finish with our last section of inequalities by doing absolute value inequalities. So to do absolute value inequalities, first, let's just talk about what absolute value inequalities are. Absolute value inequalities are really just like compound inequalities. They are really similar to what we have already done last video with compound inequalities. So they're either going to be an and, where they're coming together, or an or, where they're going apart. And then, of course, we still apply like a lot of the similar ideas that we used when solving absolute value equations. So we're kind of putting compound inequalities and absolute value equations together to make absolute value inequalities. So I'm going to look at number 1, and I'm also going to write my steps. So I'm going to do the steps while also solving for number 1. So the first step in solving an absolute value inequality is the same as solving for an absolute value equation. What we want to do first is we want to get the absolute value expression alone on one side of the inequality. So that means we want to get this x plus 1 all by itself on one side of the inequality. So first step, get the absolute value expression alone on one side of the inequality. So if I look at number 1, I am trying to get this negative 20. That negative 20 is on the same side as the absolute value expression. So I want to move that to the other side. I do that by adding 20 to both sides of the inequality. So the absolute value of x plus 1 comes down, and then greater than negative 13 plus 20 is 7. So my second step is really similar to my second step in solving an absolute value equation. Just like in an absolute value equation, we're going to split it into two inequalities. So one is going to be exactly the same inequality symbol, and the answer is the same sign. So it's going to be x plus 1 is greater than 7. So that's our first one. So it's the same inequality symbol, and the answer is the same sign. The answer is same sign. And then the second one, so before it was the same, it was equals and the same sign. And then the second one was the opposite sign. So what happens is we change the inequality symbol and we change the sign of the answer. So opposite inequality symbol. And answer is opposite sign. So what that means is it's still going to be x plus 1. Notice inside the absolute value doesn't change ever. And so because this one was greater than, we're going to do less than and then negative 7. So the reason we flip the inequality sign on the second one is to take into account that we're changing the sign too. It's kind of a similar idea behind when we divide both sides by a negative, we have to flip the inequality sign. It's the same here as well. So just like an inequality or an absolute value equation, our next step is to solve each inequality separately. So I'm just going to get x by itself. I'm going to subtract 1 from both sides. And I get x is greater than 6. That one's solved. And then I'm going to subtract 1 from both sides, and I get x is less than -8. Now, our next step and our last step is what's specific to inequalities. So our last step is going to graph the solutions and write an interval notation. Graph the solutions and write an interval notation. So your answers for inequalities should always, always, always be in interval notation. Now, one thing I want to mention and I want to make note of, because I've already talked about it, remember when we're splitting the absolute value expression, like the absolute value expression does not change. So what's inside the absolute value, that does not change at all. So when splitting, the absolute value expression does not change. Which is the same idea that we had in absolute value equations also. Okay, so let's graph this. We're just going to graph it on the same graph. -8 comes first, and then 6, because we're ordering it from least to greatest. So x is less than -8, that's an open circle. Greater than 6, that's also an open circle. So less than is going in the negative direction, and greater than for 6 is going in the positive direction. So I'm thinking, is this an or inequality or an and inequality? Remember, or is going away from each other and is coming together. So this one is actually an or inequality. So what we're going to do is we are going to write our final answer in interval notation. So I use my graph. I look at it from left to right. So we're going negative in the negative direction forever. So that's negative infinity to -8. Parentheses because it's an open circle. There's a gap, so union. Parentheses because it's an open circle. And then 6 to infinity because it's going on in the positive direction forever. And that is my final answer. And that is how you solve an absolute value inequality. Okay, so what I want you guys to do is look at number 2, and I want you guys to start that one on your own and just start with what would be the first step. What would be your first step? So pause me here, look at the first step, and try and start that step on your own. Okay, so if you're thinking, get the absolute value expression alone, which the absolute value expression is x minus 8, you would be correct. So that means we need to look what's being added or subtracted or multiplied or divide, and that's that plus 5. So I first want to undo that. I want to subtract 5 from both sides. And then I get the absolute value of x minus 8 is greater than or equal to 11 minus 5, which is 6. Okay, so now that I've gotten the absolute value expression all by itself, now I move on to my second step. So my second step is splitting them. So I want you guys to split them into your 2 inequalities. So go ahead and try that on your own. Split them into your 2 inequalities and then come back to check your work. Okay, so I split it into 2. Remember the absolute value expression stays the same. X minus 8, same inequality symbol, same sign. So greater than or equal to 6. And then the second one is the opposite inequality symbol, less than or equal to, and the opposite sign, so -6. So then I want you to solve those 2 inequalities separately and then come back and check your work. And so I get x is greater than or equal to 14 and x is less than or equal to 2. So now that we've solved our inequalities, now what I want you guys to do is graph the solutions. So just start by graphing those on your own. So graph those 2 on the same number line. Remember, we're ordering them from least to greatest. So 2 comes first, and then 14 comes second. So 2, 14, that makes sense numerically. Now, greater than 14 or greater than or equal to 14 is going to be a closed circle because of the or equal to. And then x is less than or equal to 2 is going to be a closed circle because it's the or equal to. So x is greater than or equal to 14 is going in the positive direction, and less than or equal to 2 is going in the negative direction. So now that it's graphed, I want you guys to try to write that in interval notation. So try writing that on your own in interval notation and come back and check your work. Okay, so let's see. It's going in the negative direction forever. So that means we're starting with negative infinity, and then it ends at 2. It's a closed circle, so we use a bracket. There's a gap, so we use that U. Closed circle again at 14, so we use a bracket and going in the positive direction forever, so infinity. And that is your final answer. And this one is another or inequality. They're going away from each other, so it's an or inequality, which means we have to use that union symbol to help us to write it in interval notation. Okay, let's look at number 3. So number 3 says 3 times the absolute value of 2x plus 8 is greater than or equal to 30. So again, our first step is always to isolate the absolute value expression. Remember, really important, we talked about this with absolute value equations. Do not distribute. To isolate the absolute value, we actually are going to divide both sides by 3. So again, do not distribute to an absolute value expression. Instead, divide. Okay, so to undo that, it's remember 3 times. So I'm going to divide both sides by 3. And I get the absolute value of 2x plus 8 is greater than or equal to 10. So from there, what I want you guys to do is start the next step. So start step 2 and then come back and check your work. So do step 2 on your own and then come back to check your work. Okay, so I split them into my 2 inequalities. One where it's the same inequality, same sign, and then the other where it's the opposite inequality, opposite sign. Now I'm going to solve them separately. So I'm just going to start by solving this one. I always undo the addition or subtraction first. So I'm going to subtract 8 from both sides. And I get 2x is greater than or equal to 2. And then to get x by itself, we divide both sides by 2. And I get x is greater than or equal to 1. Okay, so what I want you guys to do is I want you guys to solve the second one on your own. So solve that on your own and then come back and check your work. So same as before, first step, I subtracted 8 from both sides. And then I divide both sides by 2 to get x is less than or equal to negative 9. So now I'm just going to graph it. So we look, okay, least to greatest, so negative 9 to 1. I'm going to squeeze this in here. So it is less than or equal to negative 9. So or equal to is a closed circle. Greater than or equal to, closed circle. So greater than 1, okay, it's going in the positive direction. Less than or equal to negative 9 is going in the negative direction. So using that graph, I want you guys to write that in interval notation. So pause me and write that in interval notation on your own. And I got my answer to be negative infinity to negative 9 with a bracket because it's a closed circle, union because of the gap, bracket 1 because of the closed circle, to infinity, always a parentheses on infinity. Okay, so I want you guys to look at number 4, and I want you guys to start the first step for number 4 on your own. So start the first step on 4, pause me here, and try that on your own. So the first step, just like number 3, is to get the absolute value expression all by itself. So because that was 2 times the absolute value of x minus 3, I divided both sides by 2 to get the absolute value of x minus 3 is less than 4. So now what I want you guys to do is do step 2 and do step 3 on your own. So step 2 and step 3 all on your own. So pause me now. First step was just to split them. And then I solved for x. So I got x is less than 7 and x is greater than -1. So I want you guys to try graphing those on your own. So pause and graph them now. Okay, so you should be coming back to graph. So my graph, we have -1 and then 7. Both of those are open circles because they're not or equal to. Now, it's saying greater than -1, so that's going in the positive, and less than 7, so that's going in the negative. So what happens is this one's coming together. This one's our first and. So when it's an and like that, I always say that inequality is easier to write in interval notation this way because it starts at -1 with a parentheses because it's an open circle, ends at 7 with a parentheses because it's an open circle. And that's it. Okay, so number 5 and number 6 are kind of our special ones. So I'm going to go over those. So number 5, again, we still want to start with the first step, get the absolute value expression all by itself. So we want to add 5 to both sides of the inequality. And I get the absolute value of x plus 4 is greater than -3. Now before, when we had an equal sign and you were left with the absolute value expression equal to a negative number, it was automatically no solution. But with inequalities, we have to think about it a little bit further. Now we know an absolute value expression is always going to be positive. We always know an absolute value expression will always be positive. So a positive, it's saying a positive because an absolute value is greater than a negative. Now, does that make sense? Is a positive number greater than a negative? And it does. A positive number is always going to be greater than a negative. And so remember, if we're thinking about when we were solving and we were left with a true statement, we went to infinitely many solutions. So this one is infinitely many solutions. Now let's talk about how to graph that and how to write that in interval notation. But before we do, so an absolute value expression will always be positive. And so when we're looking at this, a positive will always be greater than a negative. Okay, so let's graph it and then let's write it in interval notation. So the graph, all it is it's just infinitely many solutions. So it's basically a number line, like an arrow going above in both directions. And so we write that it's going in the negative direction forever and the positive direction forever. So we write that as negative infinity to positive infinity. And so that one is infinitely many solutions, or all real solutions would be the same thing. But this is how you would write it in interval notation. So with 6 is also a special one. First step, we always want to isolate the absolute value expression. So I'd need to add 5 to both sides. I know they're the same problem, except the inequality symbol is flipped. So I'm sure you know where this is going. So we have the absolute value of x plus 4 is less than -3. So again, we're stuck because we have an absolute value expression and a negative. So we know an absolute value is always positive, less than a negative. Now, is it possible to have a positive that's less than a negative? No. So this one was a true statement and it was infinitely many solutions. This one is a negative. No. This one is a false statement and it's no solution. There is not a way to write that in interval notation, nor is there a way to graph that. So you just write it as no solution. So again, the reason why that one is no solution, an absolute value will never be less than a negative number. Because an absolute value we know is positive will never be less than a negative number. So whenever you get to a negative, like once you've isolated the absolute value, once you have a negative, because see how all of these other ones were positive, positive 10, 4, 6, and 7, those you can split. If you have a negative, that's where you have to stop and think. Is it infinitely many solutions or is it no solution? Infinitely many solutions is when the inequality is true. No solution is when the inequality is false. So again, I would cut this out, glue this into your spiral, and that is it for the notes. And that is it for this section for inequalities. So we'll start reviewing and preparing for your test soon. Have a great day, guys, and I will talk to you soon. Bye.